The world keeps evolving. The times keep changing. The new generation of technology. The new generation of information. They bring the future before us. Institut Teknologi 10 November, a place where the spirit of heroism underlies the new generation to research and innovate in technology. The University of Heroes, ITS. ITS is one of the best science and technology universities in Indonesia, which was founded by Dr. Angga in 1957. In every step, ITS focuses in advancing education, research, management, and community service. As an incorporated public university, ITS has been able to manage autonomously the policy of academics, organizations, finance, students' affairs, human resources, facilities, operational, and infrastructure.
In the spirit of Indonesian heroes, during the battle in the 10th of November 1945, ITS always makes efforts to be the best in education, research, and community services, especially in the fields of industry and maritime. ITS also actively contributes to the nation development, and in the future, ITS will become an entrepreneurial university with world-class reputation.
ITS has many achievements. Both national and international achievements prove that ITS keeps growing and gives the best contribution to the nation of Indonesia. ITS is a place for new hopes to grow. An ideal environment for the new generation to flourish in 3 strategic locations within the industrial city of Surabaya. As a smart eco-campus, ITS maintains harmony between technological advances and the sustainability of the surrounding ecosystem. ITS has 7 faculties with prospective scientific fields, including Scientics, INSYS, Vocation, Creatis, MarTech, Electics, Plan. ITS is a space for the new generation who are hungry for knowledge because it provides a wide range of references in both physical and digital form. ITS makes it easier for the new generation to access information by providing flexible classes. ITS keeps moving forward in facing future challenges by providing the best facilities for the new generation's activities. The facilities support both spiritual and physical needs. ITS also provides research facilities in the ITS Science Technopark, including ICT and robotics, automotive, maritime, and creative industries. Therefore, the excellent generations from ITS will emerge and make history. ITS is a space for the new generation to express themselves. ITS is a place where the new generation learns new things and finds their purpose. ITS has become a place where the new generations that carry the future will be born.
ITS is a campus of science and technology, which focuses on the research and innovation, presenting technology for prosperity.
With a spirit of heroism, ITS brings the future before us. ITS, the University of Heroes.
Give me reasons to doubt, try to keep me down, but I'll put the flame out, you can't get to me. Throw your sticks and your stones, go break all of my bones, you won't ache my soul, you can't get to me. And there is no barricade that I can tear away. Shoot me down to fire away, away. But I'm a heavyweight. I'm a heavyweight. I'm a heavyweight. I'm a push me down to the ground. What goes around comes around. You won't put the flame out, you can't get to me. Say what you wanna say, go take it all away. But I'm here to stay, no you can't get to me. And there is no barricade that I can tear away. Shoot me down to fire away, away. But I'm a heavyweight. I'm a heavyweight. I'm a heavyweight.
Some members, some students from our university, members of our association, a few years ago went to USA for the Chem-E-Car Competition, and they met the Indonesian team. They told them about the competition at Indonesia. They went there, and we decided to repeat this.
From Utamina University.
So happy that we have met all of the participants, all of the committees, all of the judges. They were so kind and they were so welcoming for us to be here. And since this is our very first experience, we feel very proud of it.
world keeps evolving. The times keep changing. The new generation of technology. The new generation of information. They bring the future before us. Institut Teknologi 10 November, a place where the spirit of heroism underlies the new generation to research and innovate in technology. The University of Heroes, ITS. ITS is one of the best science and technology universities in Indonesia, which was founded by Dr. Angga in 1957. In every step, ITS focuses in advancing education, research, management, and community service. As an incorporated public university, ITS has been able to manage autonomously the policy of academics, organizations, finance, students' affairs, human resources, facilities, operational, and infrastructure.
In the spirit of Indonesian heroes, during the battle in the 10th of November 1945, ITS always makes efforts to be the best in education, research, and community services, especially in the fields of industry and maritime. ITS also actively contributes to the nation development, and in the future, ITS will become an entrepreneurial university with world-class reputation.
ITS has many achievements. Both national and international achievements prove that ITS keeps growing and gives the best contribution to the nation of Indonesia. ITS is a place for new hopes to grow. An ideal environment for the new generation to flourish in 3 strategic locations within the industrial city of Surabaya. As a smart eco-campus, ITS maintains harmony between technological advances and the sustainability of the surrounding ecosystem. ITS has 7 faculties with prospective scientific fields, including Scientics, INSYS, Vocation, Creatis, MarTech, Electrics, Plan. ITS is a space for the new generation who are hungry for knowledge because it provides a wide range of references in both physical and digital form. ITS makes it easier for the new generation to access information by providing flexible classes. ITS keeps moving forward in facing future challenges by providing the best facilities for the new generation's activities. The facilities support both spiritual and physical needs. ITS also provides research facilities in the ITS Science Technopark, including ICT and robotics, automotive, maritime, and creative industries. Therefore, the excellent generations from ITS will emerge and make history. ITS is a space for the new generation to express themselves. ITS is a place where the new generation learns new things and finds their purpose. ITS has become a place where the new generations that carry the future will be born.
ITS is a campus of science and technology, which focuses on the research and innovation, presenting technology for prosperity.
With a spirit of heroism, ITS brings the future before us. ITS, the University of Heroes.
Give me reasons to doubt, try to keep me down, but I'll put the flame out, you can't get to me. Throw your sticks and your stones, go break all of my bones, you won't ache my soul, you can't get to me. And there is no barricade that I can tear away. Shoot me down, go fire away, away. But I'm a heavyweight, I'm a heavyweight, I'm a heavyweight, I'm a push me down to the ground. What goes around comes around. You won't put the flame out, you can't get to me. Say what you wanna say, go take it all away, but I'm here to stay. No, you can't get to me. And there is no barricade that I can tear away. Shoot me down, go fire away, away. But I'm a heavyweight, I'm a heavyweight, I'm a heavyweight.
Some members, some students from our university, members of our same association, a few years ago went to USA for the Chem-E-Car Competition, and they met the Indonesian team. They told them about the competition at Indonesia. They went there, and we decided to repeat this.
From University.
So happy that we have met all of the participants, all of the committees, all of the judges. They were so kind and they were so welcoming for us to be here. And since this is our very first experience, we feel very proud of it.
When the sun comes up and the crowds arrive, this place will come alive, and we will be, yeah, we will be united. We'll be when the sun comes up and the crowds arrive, this place will come alive, and we will be, yeah, we will be united.
The world keeps evolving. The times keep changing. The new generation of technology. The new generation of information. They bring the future before us. Institut Teknologi 10 November, a place where the spirit of heroism underlies the new generation to research and innovate in technology. The University of Heroes, ITS. ITS is one of the best science and technology universities in Indonesia, which was founded by Dr. Angga in 1957. In every step, ITS focuses in advancing education, research, management, and community service. As an incorporated public university, ITS has been able to manage autonomously the policy of academics, organizations, finance, students' affairs, human resources, facilities, operational, and infrastructure.
In the spirit of Indonesian heroes, during the battle in the 10th of November 1945, ITS always makes efforts to be the best in education, research, and community services, especially in the fields of industry and maritime. ITS also actively contributes to the nation development, and in the future, ITS will become an entrepreneurial university with world-class reputation.
ITS has many achievements. Both national and international achievements prove that ITS keeps growing and gives the best contribution to the nation of Indonesia. ITS is a place for new hopes to grow. An ideal environment for the new generation to flourish in 3 strategic locations within the industrial city of Surabaya. As a smart eco-campus, ITS maintains harmony between technological advances and the sustainability of the surrounding ecosystem. ITS has 7 faculties with prospective scientific fields, including Scientics, INSYS, Vocation, Creatis, MarTech, Electrics, Plan. ITS is a space for the new generation who are hungry for knowledge because it provides a wide range of references in both physical and digital form. ITS makes it easier for the new generation to access information by providing flexible classes. ITS also provides research facilities in the ITS Science Technopark, including ICT and robotics, automotive, maritime, and creative industries. Therefore, the excellent generations from ITS will emerge and make history.
Ladies and gentlemen, we cordially invite you to turn on your camera and be seated on your comfort place because in a few minutes, the ceremony will proceed in no time.
For prosperity.
With a spirit of heroism, ITS brings the future before us. ITS, the University of Heroes.
Give me reasons to doubt, try to keep me down, but I'll put the flame out, you can't get to me. Throw your sticks and your stones, go break all of my bones, you won't ache my soul, you can't get to me. And there is no barricade that I can tear away. Shoot me down, go fire away, away. But I'm a heavyweight. I'm a heavyweight. I'm a heavyweight. I'm a But I'm a heavyweight. I'm a heavyweight. I'm a heavyweight. I'm a heavyweight. Push me down to the ground. What goes around comes around. You won't put the flame out. You can't get to me. Say what you wanna say. Go take it all away. But I'm here to stay. No, you can't get to me. And there is no barricade that I can tear away. Shoot me down, go fire away, away. But I'm a heavyweight. I'm a heavyweight. I'm a heavyweight.
Some members, some students from our university, members of our association, a few years ago went to USA for the Chem-E-Car Competition, and they met the Indonesian team. They told them about the competition at Indonesia. They went there, and we decided to repeat this.
From University.
So happy that we have met all of the participants, all of the committees, all of the judges. They were so kind and they were so welcoming for us to be here. And since this is our very first experience, we feel very
Excellencies, distinguished guests, participants, ladies and gentlemen.
Assalamualaikum warahmatullahi wabarakatuh. To the Honorable President of Chernival, Mr. Arik Andika Farsya,
Head of Chemical Engineering Student Association or HIMATEKK ITS, Mr. Anggi Asrul Evando,
Head of Chemical Engineering Department ITS, Dr. Widya Stuti STMT, the representative of Altekimits, Cak Rama,
all finalists of Indonesia Chem-E-Car Competition or ICECC 2021, and all participants.
good morning, and we are very delighted to welcoming you on Awarding Day ICECC 2021.
First of all, let us introduce ourselves. I'm Diana.
And I'm Yagi.
We'll serve as the master of the ceremony for the next 3 hours.
Before we start the main event, let's first pray to God for gathering us here. Pray begins. Finish.
Then, we'd like to tell you a little information about Chernival. Chemical Engineering Innovation Festival or Chernival is an annual series of biggest agenda which organized by HIMATEKK ITS. It consists of 3 sub-events such as National Olympiad of Chemical Engineering or NOPEC, ICECC, and Driving Concert with Chemical Engineering Exhibition. This year's theme is application of technology to develop creativity. Through that, we have a mission to empower everyone for igniting their passion in this pandemic era.
For ICECC itself, It is already becoming the international scale biggest Chem-E-Car competition in Indonesia since 2011. It engaged chemical engineering students to pour their innovative ideas in developing a prototype car which is powered by chemical energy source that will safely carry a specified load over a given distance and stop. This year, we have 22 teams that already competed 3 days before, and in the end of this agenda, we will know who is the first winner of ICECC 2021.
Moving to the next agenda, we'll play the national anthem, Indonesia Raya, and also the university anthem, Himna ITS.
Then, we would like to invite the Honorable One, Dr. Widya Stuti as the head of Chemical Engineering Department, Institut Teknologi 10 November for delivering a welcoming speech. Ladies and gentlemen, please welcome Dr. Widya Stuti.
Yeah, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning, ladies and gentlemen. Thank you everyone for joining this ceremony. It is such an honor for me to speak in front of you. Let me begin by giving you a warm welcome to this event, Indonesia Chemical Engineering Car Competition, ICECC 2021. First, let us say praise to Allah Subhanahu wa Ta'ala, who give us all the favor and help to us until this day. Today, the winner ICECC 2021 is announced. Actually, victory is not the main goal, but the sportiveness that is the important thing. Also, getting to know each other between teams, moreover, at the international level, as a basis for future collaboration is also important. I believe everyone here is a true champion, a successful engineer candidate who will contribute well to your environment. Another series of ICECC is a webinar. The topic is very interesting about alternative energy, about hydrogen fuel as eco-friendly resources. Will be delivered by Mr. Danit Suryatama, PhD, and moderator by Mr. Lebda Prakoswo. So then please do not miss this webinar. Finally, I also thank the organizers, the judge, the expert team, and everyone who had prepared this event. Thank you very much for your kind attention. Thank you for your participation in this event. I do hope you are successful in your life. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, Dr. Widya Stuti, for the welcoming speech. For letting you know more, we'll announce the scheduled agenda for today. First, go to the one of the chauffeur webinar, which appoints the topic of hydrogen fuel as eco-friendly resources.
After that, there is an awarding of virtual candle given to the speaker.
And for entertaining you, we have a traditional dance performance.
And also followed by after movie of ICECC 2022-21.
Next, the one that everyone has been anticipating about, the winner announcement of ICECC 2021.
And then we will hear a speech from the first winner of ICECC 2021.
After that, there will be a closing and photo session.
And lastly, there will be a video closing to end our agenda.
So after this, we have a webinar which will be conducted by our moderator, Mr. Lebda Prakoswo, ST-CCME. But first, we'd like to introduce the moderator.
Mr. Lebda Prakoswo is a sourcing lead well services and low carbon at BP GBS Asia SDN BHD. He has 16 years professional experience in operational project procurement management, strategic sourcing, and category management inclusive in oil and gas major project in Middle East, Southeast Asia, and Europe.
In this occasion, Mr. Lebda will lead the webinar session with our speakers. Without further ado, the one and only Mr. Lebda, the time is yours.
Thank you very much, Brother Yagi and Sister Diana. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning, everyone in Indonesia. Good afternoon and good evening, global audience. So it is my pleasure to be here as moderator for ICC Chernival 2021. So today we are at topic with the hydrogen fuel as eco-friendly resources. So first of all, we praise to Allah Subhanahu wa Ta'ala. We thank Him upon all conditions. We ask Him to send blessing and salutation upon Muhammad sallallahu alaihi wasallam, his entire household, his companion. May Allah Subhanahu wa Ta'ala bless them all, and may He bless every single of us. So we are currently in good health and staying safe, so we can gather in this forum. Let's then, a bit before we start our session, let us pray for all brothers and sisters. As we know that yesterday there's the earthquake in South Malang in East Java. So hopefully there will not be many victims and be given patience for the tragedy that befell them. Okay, my name is Lebda. So now I will moderate for the webinar of awarding the ICECC Chernival 2021 with the topic hydrogen fuel as eco-friendly for future. Before we start our webinar, actually I would like to share my overview for this session regarding for the hydrogen fuel. Hydrogen fuel is a zero carbon fuel burned with oxygen. It can be used in fuel cells or internal combustion engine. It has begun to be used in commercial fuel for cell vehicles, such as for the car, and then has been used in fuel cell buses for many years. And as you know that for the hydrogen, actually there is the three types for the hydrogen. There is the blue hydrogen, green hydrogen, and gray hydrogen. But for the renewable energy, actually we need a combination for blue hydrogen and green hydrogen. Okay, so now we have a keynote speaker today.
Permute Pak Lebda.
Can you hear me now?
Okay.
Loud and clear.
Hello, can you hear me now?
Yes, okay, Pak Lebda.
It's okay?
Yes, okay.
It's okay.
Okay, so I would like to introduce our keynote speaker today. Dr. Suratama is get civil engineering from ITS Surabaya, and then he got the Master of Science in the Marine Engineering, and then he got a Master of Science Engineering for Naval Architecture from University of Michigan, and then he received Doctor Philosophy of Doctor from University of Michigan. Since 2012, he is a co-founder of electrical car in Michigan that, he developed for the hydrogen fuel cell electrical buses in Indonesia, and then in China, also in Shenzhen, China. And also that, he is a lot of published technical papers in various journal and conference. And he also filed several patents in US. So without further ado, I would like to hand off floor over Dr. Danet Suryatama. Over to you, Dr. Danet.
Hello, Assalamualaikum. Can you hear me?
Waalaikumsalam. Yes,
Okay.
how are you, Dr. Danet?
Good, Alhamdulillah. So how can I see myself? Okay, let me just shut off this. Oh, I still have that.
So I cannot see your picture.
Yeah. 1 second. Why is it not showing?
Can you turn on the video?
Yeah, I turn on my video.
Okay.
1 second.
But your voice is clear.
Yeah, my voice is clear, but let me leave it somehow. Okay. Let me do this. Okay.
Yes, I can see a car, like a taxi.
Yeah, okay. So can you, okay, there it is. Somehow, I don't have any control on my computer.
But now it's a disappear again.
Yeah, no, right now I'm fine. Okay.
Oh, okay.
Okay. Good morning. Assalamualaikum.
Waalaikumsalam.
Thank you
warahmatullah.
very much for. Should I start or should I?
Yeah. Okay.
Okay. So can I get? Let me share my screen.
Yeah, please.
Okay. Good morning. I just would like to present my work the last couple of years in the area of battery electric vehicles as well as fuel cell electric vehicles. So let me just share my screen. Okay. Good. Can you see my, okay. Let me.
Still in progress. Okay, we can see it.
Okay. Okay. Somebody else is also a co-host, right? Because people are coming into the so you see. Okay, good morning. I always love to talk to students. Basically, I've been talking to many students in the US and Indonesia, and the reason I love to talk to students is because that's where I could explain to them what I should explain, or to give them somehow a direction or compass where they should structure themselves, what they're studying, what they would like to be, or what they like to become in the not so distant future. Not so distant future is the meaning that my voice is clear, right? Hello.
Yes, very clear, very clear.
Okay.
Yeah, we can hear you.
So this is what we are doing the last several years. If you know, in 2012, when we built the electric vehicles, after that project, we moved to China. So we built the program in China, fuel cell electric vehicles, not just only electric vehicles. So that means the vehicles not only being powered by the battery, but also by being powered by the hydrogen fuel cell. So hydrogen is the storage system on the vehicles. So the bus, the red bus, is coming from the US. So we exported this bus to China, and from China we develop it further. So it's already been developed in the US, and then we develop further in China. So the reason why we do this is this: as you know, that we have issues with the greenhouse gas. We have climate change. We have global warming. Indonesia, maybe you call it global warming, but the correct pronunciation is the climate change. Climate change is actually not only create a warming up of oceans or anything in the world, but also creating a weather patterns which are not very normal. So the weather patterns that are not very normal can be seen in the US. If you live in a 4-season country, you will see that is very apparent. Something like a couple of weeks ago, Texas, I live in Michigan. Michigan is far north on the US, close to the Canadian border. So we are just only 30 minutes from Canadian border. In the winter, we are very cold. I'm talking cold is minus 10 degrees Celsius, minus 20 degrees Celsius. And then by by March, we still have minus 5, minus 10, or 0 degrees Celsius temperatures. But this year in March, we already above 0. We already 5 or 10 degrees Celsius. In Texas, which are much south than us in latitude, they are cooler than us. So somehow the northern part is warmer than the southern part. So this is the problem. The spike of the greenhouse gases started in the 1850, start of the industrial revolutions. The increase of greenhouse gases are creating significant warming up, and 25% of greenhouse gases are coming from transportation sector. And then the one that I haven't shown it over here is that 25% is coming from the industrial emission. So that is the one that is creating a lot of issues right now. So people are trying to buy clean energy vehicles, but clean energy vehicles or electric vehicles are very, very expensive. Not only it is expensive, but it is rare. In Indonesia, I can see how long it will take to get a Tesla. Or not only that, is that you have to have a long waiting line to buy a Tesla. Let's say you would like to buy a Tesla. And then electric vehicles have a limited range. That means your vehicles have a shorter range than the normal vehicles. Now, not only electric vehicles expensive, many people cannot afford to buy it. Many countries couldn't afford to build electric vehicles. Let's see Indonesia. Indonesia has not been able to build electric vehicles. When we built the electric vehicles for Indonesia in 2012, we were just 4 years behind Tesla. And then there's always something happened in Indonesia, and didn't happen, right? So that car, the one that you see on my screen, is Mitsubishi. So we moved to China. We built China. So you might not like to see that, but it happens. So now, what we're trying to say is this, that even though we think that we, Indonesia, cannot build electric vehicles or fuel cell electric vehicles, but actually that thing is a myth. You can build that. That myth can be broken. And this is how we do it. But in this case, I'm not going to tell you a story about this. So this is what we've done so far. You can see that we're still offering this, not in Indonesia, but overseas. So in the US, in China, and other part of the world. So we are gathering people to build this vehicle. Now, this is what we are building in China. This is a fuel cell electric bus. So we built several of them. So we still have 5 more as well that we need to build, and we need to go back there. But COVID is creating a lot of headache for everyone. So it is not easy to, from the US, you cannot go to China, and in China, you cannot go to US. Right now, you have to have a 14 days quarantine to go to China. So the advantage of a hydrogen fuel cell is that it will create much longer driving range. So on our bus can go like 1,000 kilometers, depending on how many hydrogen storage that we put into the bus. And then it is not constricted by the amount of the batteries that we have. Because we can put our hydrogen gas, in this case, into the bus like we fill in the gasoline in normal car. So this is what the reason why we do this. Not only that, I will explain to you later the advantage of the hydrogen or hydrogen fuel cell in terms of the environmental friendliness. So this is another one that we're building. This is actually a to-build 3-wheeler. 3-wheelers are, we are like to put it in Asia, either Indonesia or China, to help low-income families. So instead of riding a motorcycle, you ride something like this. Everything is enclosed. When you turn, the 3-wheeler is also turning, tilting, and it's got an air conditioning and everything, and then you can control it with joystick. So it's very sophisticated. Now, that's just the application for that. let's go back to the how we and why we need the hydrogen right now. So I'm going to go back. So the issues with the greenhouse gases are coming from the emission of the vehicle, create a lot of spike on the warming up. So people are trying to move away from that. One of the reasons why they move away is through the hydrogen. So to clean renewable energy sources. What are those? Clean renewable energies are energies being harvested being obtained from environmentally friendly sources. And during collections, we do not create destruction on the environment itself. So think about this. When we do trying to create energy coming from the environmentally friendly sources, we do not create destructions on our environment. So the energy also should not create what it's called emission that cause the greenhouse the effect rumah kaca in Indonesia, the greenhouse effect. So that is what we call it clean renewable energy sources. Now, one of the most important source of clean, environmentally friendly energy is hydrogen. But the way to produce hydrogen, as told by Pak Lebda before, is a bit cautionary. That means there are three kind of hydrogen type. It's called gray hydrogen, blue hydrogen, and green hydrogen. I believe that's correct, right? So the gray hydrogen is coming from the hydrocarbon. The
Electrolysis.
The side when you heat reform the hydrocarbon, you will have a side results, which is actually hydrogen. When you do that, you still create a lot of pollution. So that means you still have a positive emissions. It's not carbon neutral. It's positive carbon emission. So the blue hydrogen is actually coming from the natural gas or something else. I forgot. It's called blue is because the process is not creating. It's creating, but it being offset because of the good nature of hydrogen, that it will create what it's called a neutral carbon. But the good one is the green hydrogen. The green hydrogen is actually not creating carbon, but process is minus. It's creating an energy without any carbon or greenhouse gases in the air. So this is the process that we usually do. We are working over here in China, but we still somehow over here. So the way we do it is you do the solar power to create electrolysis on the water. The electrolysis create a hydrogen gas, and hydrogen gas, you put it into the fuel cell and create electricity. So what is the problem with this? Well, actually, there is no problem with this, but the problem is sometimes when you do a solar cell or a solar panel to create electricity, you can just create electricity and then you put the electricity into battery electric vehicle instead of a fuel cell electric vehicles. And if you could see battery electric vehicles, the process from solar to electricity can be direct instead of doing water electrolysis, hydrogen gas, fuel cell, electricity. So why do we have to go this route instead of going directly to here? There's a long story that I mentioned to you, but I don't know if I have time to do this. But the process to create, to mining nickel, cobalt, manganese, this work has been creating, and lithium is creating a lot of destruction. You see there is a place in Indonesia, in the Sulawesi Tenggara, where nickel is being mined heavily. That area is completely polluted right now, not just only water or soil, but also air and people. The people are getting sick and they cannot do anything. And it's just creating a big environmental destruction. So now, let's go back from this point. I would like to know, I would like to let you know that actually hydrogen gas and create fuel cell and create electricity. So this has been done for the last 120 years. So many scientists to create a fuel cell, either coming from hydrogen or some other sources. But what is the process to do that? So this is the process that we are working on. So you know, I believe you already have a project in this thing in the chemical engineering. This is a chemical engineering, right? Not the other one, the chemistry department.
Yes, chemical engineering department.
Okay, so this is I think I've seen your project, and I also see another project in ITS, the material engineering department that built the another car, fuel cell car called Antasena. So the two teams in ETS are very good. You should keep going. You should keep working on what your project. But I would like to give you some overview or the global framework or the basic guideline on how and what you should do in terms of technology that you are bringing right now. So let's just go back to the hydrogen proton. So there are a couple of several types of hydrogen. There are several types of fuel cells. First is, you might already know, is called the hydrogen proton exchange membrane or polyimide electrolyte membrane fuel cell, and the other one is called a direct carbon fuel cell, DCFC. What are those things? So you know that the PEM one, we call it proton exchange membrane, is called the proton exchange membrane is because there is a membrane electrode assembly like this one here that will separate the ion of the hydrogen and the proton, and the ion will go through a load that creates electricity, which is this one, and then the proton will just go to the cathode mix with the air and then create what do you call it, the emission, which is actually the water. So the direct carbon fuel cell is a bit different. So instead of doing hydrogen gas, in this case we use a carbon solid carbon that will mix with the MEA as well. In this case, the anode is from is made of a carbon anode, and there is electrolyte in it. It's usually molten sodium, I forgot the name. And then the cathode is made of some metal alloys, and it'll go on the anode side. The carbon is put in, and then from the anode side, the air is heated up, and the process is using a heat as the agent to create the process, and then you end up with the electricity coming on the load side. So the process is different, but the result is the same. Basically, carbon DCFC creates CO2 as the emission. The hydrogen PEM creates water as the emission. Now, when we're talking about CO2 in the direct carbon fuel cell, you might think that, whoa, so we try to avoid CO2, pure CO2 or CO2 coming from the industries or the gas emission, and how come we are creating CO2 here on the carbon fuel cell? Well, actually, the story of a carbon fuel cell is a half story. I'm not going to tell you the other one. I'm not going to explain to you in a very detailed one, but I'm just going to let you know is this, that this is part of what it's called a carbon sequestration, or you might think it the other way is called carbon capture process, in which you capture carbon dioxide, CO2, and then you could sequester it, or you capture it, or you put it into injecting it into a well, and some of the process, the well will be reacted with salinity or certain salinity level and create electricity. That is in the future, but the current process is what it's called the carbon capture. The carbon capture is capturing carbon dioxide on the air and then sequester it or save it into a well underground. So this process is actually coming from for a couple of other processes that comes with it, and that's, it's not just working by itself. So that is why the DCFC is actually good for power generation, stationary power generation, while the hydrogen PEM is good for vehicle power. So in this carbon fuel cell, if we feed the CO2 as well with the CH4, then the methane, then you will end up with the hydrogen. And that is another process that people are working on right now. So basically, the whole process over here is electric generations without creating an emission. Even though you, at this process, you still are creating CO2. So now, let me, for the hydrogen PEM, what is the efficiency of the hydrogen compared to the direct carbon fuel cell? Of all of the fuel cell types, direct carbon fuel cell is the most efficient. It's got like 80% efficiency, 70% efficiency, while the PEM, the polymer electrolyte membrane or proton exchange membrane, only has around 60%, depending on what kind of voltage level or current that you already have. But the good thing about the PEM PEM fuel cell is that it is operating in a lower temperature, while this carbon fuel cell operating between 800 to 1000. The polymer, the PEM, only operating at below 120. It says over here, but this is an old table. Our experience said that we only at the time operating at 80 degrees Celsius. So it's comparably cooler than the vehicle engine. So that's what we like about the hydrogen fuel cell. So it's not creating emission. It's not creating heat, but at the same time, it can be what do you call it, started quickly. So in this table, I will show you, I have several type of hydrogen. First is called PEM. I already mentioned to you. The second one is alkaline fuel cell. The next one is phosphorus and molten carbonate. These two are less popular. The last one is called a solid oxide. Solid oxide is almost similar to the fuel cell, the DCFC, the direct carbon fuel cell. But solid oxide has been used by NASA to create energy in the space station or in the Apollo program. So that is a different kind of fuel cells. So Well, I was going to compare to you between the proton exchange membrane and what it's called anion exchange membrane, or alkaline anion exchange membrane. What are those? The AEM and the PM. So you remember the original process in chemical engineering? Students should know this process. I'm not a chemical engineering student, but I remember I have to study this process too. So basically, what is called the proton exchange member is called cation exchange member. What it means by cation exchange member is that a membrane that only allow proton to transfer, to exchange, while the electron going to the external load create electricity. While the anion exchange membrane only, so this is a bit different. Anion exchange membrane, instead of going the exchange, instead of going from anode to cathode, this one here from cathode to anode, the hydroxide, the anion, is just anion. It's exchanging from the cathode to merge with the fuel from the anode side, and at the same time creating load for the electron. So this process is in the opposite direction than the PEM. But the nice thing about the AEM is that it can use much lower grade platinum, lower grade metal. You don't have to use a very expensive platinum. You see the hydrogen fuel cell, the most expensive parts is the catalyst, which is actually using platinum and some other alloy. So this is the issues of the PEM right now, and that's the reason why the fuel cell is very expensive. So this is the problem, the difference between these things, not just the AM and PM. You might like to see. Another thing is that the AM always have a problem with the CO2 interference, while the PEM always get a problem with the gas leaks coming from the anode side, or the electron, instead of going to the outer load, it will go through the membrane, the MEA, and create a short circuit. So that is a story about that. I'll just explain to you now. Let me just, hey, what's going on? Okay. The next one. So what is different between the fuel cell and the electric battery electric vehicles and fuel cell electric vehicles? In our vehicles, when we build the battery electric vehicles, the source of the power source is just battery pack. The electricity coming in, being charged into the battery packs, it propel the motors, the car's running. So this is very simple process. So at the fuel cell electric vehicles, there is another stage that we use, which is called hydrogen fuel cell. Now, instead of battery coming from the charging process, now we can refill the hydrogen. The hydrogen create electricity will be charged into our battery pack, and it will create the power. So basically, the two are similar electric vehicles. It's just in the hydrogen fuel cell electric vehicles, we have an extra units called the hydrogen power module. At the same time, hydrogen power module, hydrogen fuel cell over here, do not have to charge the battery. It can go just directly from hydrogen fuel cells to the motors. So there you go. So this is how it looks. I hope I don't get you bored, don't make you sleepy. So this is a stack. This is what we built in our vehicles in China. These are the stack, the fuel cell stack, call it. The fuel cell stacks consists of membrane electrode assembly, the plates, the cooling plate, and then the gas plate, and they all stack one by one. Each of stack is one cell. So we have one unit over here is 30 kilowatt. So you have a 2 unit, which is actually 60 kilowatt, 2 times 30 kilowatt. On the other vehicles, we have 1 unit, and this one is also 1 unit. Some other vehicles, we're not going to show it to you. One other thing is that you can, as you can see, that there are what it's called cylindrical equipment which is connected with high pressure delivery system. So those, I'll explain to you later. Those are what we call it the hydrogen storage system. Our hydrogen storage system has to be able to sustain a very high pressure gas, hydrogen gas. In this case, it can go 35 megapascal, but it can also go 550 megapascal, 50. So it has to have also delivery system. So the delivery system is this high pressure pipe delivery system. It's supposed to have a flow control system, because from this point you have 35 megapascal and you enter into the fuel cell that just only has 630 kilopascal. So you have to go 35,000 lower to enter the fuel cell power modules. So on top of that, we have to have what is called a deionized water system to cool the fuel cell. We have to have an air compressor to feed in the air on the fuel cells. We have to have an HVAC, a complete HVAC, as well as the electronic control system. So these are all, in this case, the maker provide us with several components, but we have to assemble it ourselves. So we built some other system on top of that. So it's very complex compared to the to electric vehicles only. So what's going on here? Okay, let's just go back. Okay, so I'm not going to end this, but I'm going to show you something after this. But what you might like to take out from this seminar is that there are many applications that you could build with the hydrogen technologies, from the vehicles, the house, the aerospace, and the train and the ship. Those transportation mode or transportation vehicles can be powered using a fuel cell. So the idea with a fuel cell right now is to go to the second level here. This is the, oh, sorry. So this is the second item over here, is the most important thing. You might like to pay attention here. So you might have seen SpaceX launch in the YouTube, and then the landing of the Perseverance rover over in Mars several months ago, a month ago, and then today, a couple of days ago, the drone, which is actually the observation drone called the Ingenuity, is being dropped, and then it's supposed to be in the US time, so tomorrow afternoon. That means tomorrow on the Monday early hours in Indonesia, the drone is supposed to go up in Mars. So the idea of the whole hydrogen power system is not actually to only make our world cleaner, which is actually, we would love to have it. But the most important thing is actually to make us go to Mars. And if you think you're in Indonesia, you might think, those are Americans. They're always dreaming like crazy, so let them dream whatever. No, 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 it's not. You're a new generation. Your thing, you will go to the 4-year college, graduate, find a job, and that's about it. No, the world right now is super connected. As a proof of interconnected world is me over here. I'm from Indonesia, but I'm overseas. I work in China. I work in the US. I work in Indonesia. I have some project in Indonesia that I cannot say to you. Not only that, you talk to me in the US right now. So that shows how interconnected the world is right now. So if you think you only live in Indonesia, you cannot do anything, no, it is not. You live in Indonesia, put your dream as high as possible. Don't just dream that you will go someday to Mars only, but just go to the end of the universe. I'm sorry, the end of the solar system. Go to the Io, explore Io. Go to Titan, explore Titan. You know what it is? Just go find it in Google. So the idea is this for me, is that when you graduate, your playground or your workplace, it's not just Indonesia. Indonesia might give you some nice comfort, close to the family, good food, but no, it's the world expect you to play beyond Indonesia. You should aim yourself to work out of Indonesia. You should engage with the people from outside of Indonesia. So do not put yourself constrained into just thinking that, oh, I just live in Indonesia, so this is it. No, even though Indonesia is a big country, the technologies of the world is much more than the one in Indonesia. So that's the idea. That's the reason why I'm telling you right now. So your job is actually to take us to the moon, to the Mars, using the hydrogen power. The reason why I'm saying is that right now, if you play around with the hydrogen power, you could change the fuel of the jet engine. Instead of using the F-fuel of the jet engine, you use hydrogen, and then the electricity is being used to propel the compressor. So you will end up with a much bigger thrust on the jet engine. At the same time, you reduce the weight of the jet engine. So you will end up with a much faster jet that creates what it's called later the scramjet. The scramjet is called the supersonic scramjet. That can go like about Mach 7 to Mach 17, I believe it's more than that, and then create what it's called an SSTO, single stage to orbit. That means they're playing just like in sci-fi right now. You see Star Trek or Star Wars. I don't know if your generation go to, what is it, Metalcraft or something. It could go from the Earth, just go zoom up to the outer space. So that also create what it's called the ion thruster beam. Ion thruster is actually an electric thrust. So those are the things that you should think when you start playing with the hydrogen. And for me, I will create this technology. Oh, 1 second. Oh, why is my? There it is. So another take out from this is this, that there are a couple of sides of development. This interconnection or intercooperation between agencies and not just for Indonesia only. In the US, the government's always helping the business. All government always help the universities. Universities help the companies. Companies help the universities. So dependencies are there. So in our case here, we could help you play around with your technology. If you have fuel cell project, or you would like to compete in a fuel cell, international fuel cell vehicles, you might like to also, I mean, we could offer you help. That means we could offer you technology know-how and what to do and what to buy and what to do and something like that. So with that, I'll just stop you right now. No, but I'm not going to stop first. I'm going to go to, no, 1 second, what to do right now. Okay, okay. I'll show you our vehicles. So it's just at least to go give you, okay, there it is. I hope it works. So this is our vehicle in China. I hope it can be, it was 5 years ago, right today, almost. And this is the fuel cell that the way we filled the fuel cell in China, in our bus. So this is how we fill the bus with the gasoline fuel cell. I'm sorry, with the fuel cell. This is the fuel cell. Very much like a normal normal electric vehicles. Once the gas is there, it will create the pressure control start showing the this is the control system of the fuel cell. So there are two fuel cells, A and B. This is where the fuel cell is located. This is the Chinese DC-DC converter. You can see that so big. American built much smaller, the DC-DC converter. Okay, this is some of our engineers. Okay, you can see something over there. The engineers are from Indonesia. And then we also have a team from China. So we merged two teams from Indonesia and from China. But I recruited several engineers from Indonesia. The guy who's he's a technician from Jogja. So this is the bus that runs on a fuel cell. This is the place where we build the fuel cell. So the bus is huge. It's 14-meter bus. It's one level, 14-meter bus. This is American bus. It's Volvo, but it's made at the US. Sorry, it's in Canada. Canadian company. So we refit the bus from a normal bus into the fuel cell bus, and then we change the transmission system, and then we change the engine and create a motor and create the fuel cell buses. We also have several other buses over here, like this, but small. So I think pretty much it right now. Just stop sharing. Thank you very much for your attention. I hope I don't get you bored. So if you have any questions, go right ahead. Thank you. Assalamualaikum.
Oh, Assalamualaikum warahmatullahi wabarakatuh. Thank you, Cak Danet, for your explanation. This is very interesting because you know that you are just not a chemical engineer, but you can explain this is very well. So, you know, now, yeah, before we start for the Q&A, so I actually that, yeah, for everyone that you have a question, you can type in the chat box, or maybe you can raise hand, so you can direct us to Cak Danet. So, Cak Danet, for the first question that, you know, we have the question from Pak Praharso. So, in the context of Indonesia, how can we find its hydrogen sources easily to fit into power cell pack?
In Indonesia, the hydrogen is already there. We use it for doing the industrial works. I think it's sold on the cylinders, just like in the argon for welding. Hydrogen is used for something else, and also being used for the hospital. So right now, the price of hydrogen is more than the gasoline, I guess, but it's still cheaper if you take into account the efficiency of the electric vehicles, which is actually 80-90%.
So maybe if you have maybe your research regarding for the fuel cell, so actually what is the competitive price? It means that how many, I don't know, is it cheaper than electrical vehicle, or yeah, how much that you can calculate maybe per kilometers, like $1, $2 right now for the current situation.
The electric vehicle compared to with electric vehicles right now, you're talking about the battery electric vehicles. We're talking here the fuel cell electric vehicles. Those are all the same electric vehicles. Just the other one is battery, the other one is fuel cell.
Yeah.
The battery electric vehicles, it's a bit cheaper, but the problem with battery electric vehicle is that the range is not there. With a fuel cell electric vehicle, you have a long range. The fuel cell electric vehicles are very good for heavy vehicle, and you can see that our car are very heavy. It's a huge, humongous bus, 14-meter bus. I think in Europe it's in Indonesia you haven't seen that huge bus, I guess, right? The biggest in Indonesia is like 13 meters. This one is 14 meter, and it's got like a 3.6 meter height. So not only can be used for the bus, can also be used for the intercity trailer truck, the same like the intercity buses. So that is where the use of hydrogen fuel cell is more efficient compared to battery electric vehicles.
So it means that how many kilometers that when we use the for the fuel cell vehicle?
That depends on the storage capacity, as well as the power. But the fuel cells can go much longer, just like 1,000 kilometers.
Oh,
almost
nice.
there.
Yeah. Okay. Yeah. There's the second question, Cak Danet. This is from our student for chemical engineering department. So yeah, I'm Kenny from ITS. So I think green hydrogen can be the future of the renewable energy because of how clean and high its energy density. But regarding for I heard that for the efficiency of the storing electricity into hydrogen via electrolysis, that storing the hydrogen and converting back to electricity has an efficiency of half of that from battery. So how important is efficiency in building renewable energy?
No, the efficiency of the fuel cell is about 70%, 60 to 70% right now, the PAN. So it's still pretty high compared with the battery electric vehicles. Battery electric vehicle has a higher efficiency, which is actually 85%, 90%. Fuel cell electric vehicle has 70%. But I mentioned to you before, right? The fuel cell electric vehicles are for huge vehicles, for industrial vehicles that will go from city to city. You cannot use passenger electric battery electric vehicles right now to go over 1,000 kilometers, let alone 700 kilometers.
Yeah, I think it's
First,
still
second, when
like a
you
300, 400. Yeah, go ahead, go
yeah,
ahead.
like, and also when you charge the electric vehicles, it's gonna take time for you to charge it. The fast charging right now, that is actually the 100 kilowatt charging system, can charge the 100 kilowatt at about 1 hour.
Yeah.
Or if 100 kilowatt charging point is very rare, even in Indonesia, it's just only maybe around 50 kilowatt or maybe 30 or 20 kilowatt. So you can see how long it will take to charge it. Well, you see that when one of my engineers fill in the hydrogen in our bus, it just only take a couple of minutes. It's exactly the same like when you fill in the gasoline in the normal vehicle. And the gas and the fuel is coming from water. So
It's free.
Powering your vehicles with water.
Yeah. So it means that we can have I don't know, yeah, because for the water, as a current situation that all the company that they are thinking how to serve for the water by 10 years, I think by 2035, that maybe all the people we can facing for the water crisis. So how do you think about this? Because now all the I think that all the company, like for the alliance company, for renewable company, that now they are preparing how to produce the water. How do you think about this, Cak Danet, for the future, for the hydrogen fuel cell for the car?
Well, actually, waters are very abundant in our world. We have 70% of our planet is water. It's just about the management of water. Clean water is not good. So we don't need to worry about the waters. Water are so many. 70% of the earth is water. So what do you mean?
Yeah.
It's just how to manage it is the most important thing.
Yeah. Maybe can you I don't know what is your calculation now, because as I know, for the battery electrical vehicle, that the effect the cost, like in Indonesia, that I heard and I saw that because based on the testing, that the operational cost, that like 195 rupiah. It means that how many cent, yeah, in dollar. So how about the hydrogen fuel cell? As you know,
It's the same as it's not as expensive as the it's very similar to, okay, right now, like this. Hydrogen is less, it's still a bit more expensive, and the in Europe it's still seven euro per kilogram. I guess in the US it's about same, but if you go with the gray hydrogen, it's about 1.5 dollar per kilogram. So, and when you fill in your car with a gray, even with a gray hydrogen, it's already cheaper than the gasoline, but you don't create emission. So there are more benefit as putting a fuel cell than a problem. In the US already have a plan in the year 2030 or 2045 that the entire economy is based on non-fossil fuel, and hydrogen is one of the the hydrogen is the uh, source of energy. Europe is also putting it that way. In Indonesia, I don't know still about the plan, but we're supposed to put a plan to use hydrogen as the energy source. Either hydrogen is coming from the site, what do you call it, heat reforming of hydrocarbon, or from natural gas, or some from water electrolysis. But by using hydrogen, you will get more benefit because you do not create emission. If you use a gray hydrogen, you will create emission on the hydrocarbon side, but that emission is less than if you use gasoline car, because you use gasoline gas, you create emissions on creating the fuel, and then you create another emission when you use that fuel. Using a hydrogen, if this is gray hydrogen, you create a emission when you build a hydrogen, but you don't create emission when you use the hydrogen. Now, think about when you build the hydrogen, getting it from water, which is actually zero emission. So that is what the aim for right now. So Indonesia should do that. I mean, the student over here are the next generation of Indonesians. You do not think about like my generation or generation who are running in Indonesia right now. That's not the way to run a country. But what you have to do is you think forward, you think ahead, you think 20 years, 30 years from now, what we're supposed to do. This is my work, is to actually create a better work for your generation. Now your generation should be thinking like this. Oh, by the way, what should we do to create a better world for for our next generation? And in this case, Indonesia should put an effort, a plan on how to create energy in the future. It is not hydrocarbon. It is not oil anymore. Oil is gone. Bye bye.
Yes, yes, yes. It's very interesting. So, yeah, there's another question that hydrogen fuel cell vehicle for from the green hydrogen. Is it possible apply in Indonesia in the future?
Yes.
Because is it possible? Yeah.
Yes.
And yeah, it's very possible. But maybe what is your idea? So it means that until today that Indonesia is because you have the experience to build the electrical vehicle by 9 years ago. So what is the challenge if we will build the fuel cell electric vehicle in Indonesia? Because this is very, very interesting. How do you think about your because you have the experience, yeah?
Okay. Now, the challenge is not the technical. The technical challenge is very simple. You could build something, technologies, you build it, you make some changes, you created something. It might be not, what do you call it, not perfect, but you could redo the engineering process and you create a very good results for that. That's engineering wise. The more difficult one is social education. Social education is to change the paradigm of thinking, to change the way we think, the way we do something. Let me tell you something right now. Even with the electric vehicles in Indonesia, it's not possible to deploy electric vehicles in Indonesia. You know why? Indonesian houses, most of the time, only have 2,000 watt or two, maybe, and people who are rich enough will have like 5,000 watt capacity in their house. So I'm talking about the small electric vehicles, about 30 kilowatt hour, which is actually 30,000 watt hour. That means to be able to charge that, if your house only have maximum of 3,000 watt, you have to use it for 10 hours. In 10 hours for 3,000 watt, you cannot do anything. Your electricity in the entire house is done. Now, first, second, Indonesian electricity company, I don't know how the whole problem is. Now, if a household saying that, oh, by the way, PLN, could you help me? I just bought a new electric vehicles. Can you increase my allowance of electricity in Indonesia for my house to, let's say, 10,000 watt? They'll say, okay, but I'll give you a industrial rate, which is, it's not possible. Or in the normal house, I'm talking a small electric motorcycle or small electric three-wheeler that we built. It's only 3,000 watt. If your house in an apartment, you might only have like 1,200 watt. How are you going to supposed to charge that for a second now? If your house cannot charge it, where are you going to charge it? Outside? There are not many charging stations in Indonesia. They plan to build many, but it's not going to be that many that will be able to help people. First, second, Indonesians love to go a bit farther. So Indonesian always saying that is it irit enough? irit is the mobilnya irit apa enggak nih? Kalau nggak irit, mereka nggak akan mau beli. That's the problem. So from my experience is this: to change to create the technology is simple. To change the way people think on doing things is much harder. So when we introduce our electric vehicles in Indonesia in 2012, many people just say, "Oh, the car is nothing. Your car is garbage," and stuff like that. But no, actually, that car is just only 4 years behind Tesla. Now Tesla is very good. But the problem with Tesla is that they didn't want to build a factory in Indonesia. They want to build a factory in India. You know why? I'm not going to give you an answer, but think deeply. Why Tesla didn't want to build a factory in Indonesia? Instead, they moved to India. What's the problem? Because Indonesia has less human resources? I don't know. I don't think so. Is India more advanced than Indonesia? I don't know. I don't think so. But they moved to India. So think about it deeply. Students should think about something like this deeply and think deeply. This is not about question about politics. I'm not talking about politics at all. I'm talking about technical challenges that you think that this is the a normal thing that you think you might see. So sorry, I'm going.
Yeah, it's very nice. Because as I know that actually, Tesla, they have the planning to build the factory in Batang in Central Java, but suddenly it's a change and move to India. I think for overhead costs and everything is for the cost. I think it's cheaper in India. I think because as you know that all I think it's almost all the companies create and open office in India. Even like BP, like me also, just open the office in India. So yeah, next there's another question, Chananet. So, what is the phase of the hydrogen stored in the car? Is the pressure of the hydrogen is the car posted to its user? For example, that during collision or not?
Every car has a hazard. So if you drive your car right now or your motorcycles, if you don't know the hazard of the motorcycles, that means you have to learn more about the flammability of the gasoline. The gasoline can easily. Now, in the hydrogen car, the gasoline is being stored in a very high pressure. but it's got some kind of what's called pressure relief valve. The pressure relief valve, there are not just only one, but so many. If there is a spike on the pressure, it will just release the gases. So that's it. And then that's first. The second is that the storage system is capable to sustain a very high pressure, outside pressure. So if there is a big pressure coming, and in the case of accidents, if it came off, it will just come. It will just spew out the hydrogen. Hydrogen is not very hazardous if you are an open setting. So that means in there is a big accident outside. It's not like, don't think about Hollywood. You're thinking about car in the movie and then hit something and boom. That's Hollywood. It's garbage. Sorry, I know Hollywood is full of garbage. It's not going to happen like that. It will just come crash on something. It will just release some gases, and that's it. It's not going to do anything.
So actually, yeah, this is the talk about the safety. So how do you think, as per your experience, because you already practice and produce the fuel cell vehicle, that if any accident, so what will happen? So it means that it's more safely than the fuel vehicle.
Yeah, the same pretty much. The problem with the hydrogen is it's not on the accident side. In the accident, they're supposed to be fine. The problem with the hydrogen is the filling. When you fill the hydrogens, you're supposed to be an open area. First, second, there's not supposed to be a spark. Spark mean what do you call it? In Indonesia is
percikan api. Yes.
Yeah, if there is a spark, but in Indonesia, some of the country is very wet. So usually the way we avoid spark is you do not create a very dry area around the hydrogen. And then hydrogen, if there is no spark, it's fine. Even if you're smoking next to a hydrogen gas car in open space, it's safe. No problem. But
So
if you
it
play
is,
around with
yeah.
the hydrogen exhaust, you put it in a fire, it will just shoot out a jet, which is fine.
Okay, so it means that you are thinking that for the safety reason, so for the hydrogen fuel cell, it means that more safely than the fuel combustion vehicle, like a current vehicle, yeah. So but maybe but we have to avoid the spark. But you know that this is it. It means that the people should be aware about the safety and how to operate, because this is for the literation and the knowledge how to use the hydrogen. So I think that this is for in Indonesia for future vehicle is very interesting, and for the renewable energy also. So okay,
There is a question over here from Pak Bambang Permadi.
Yes.
If I can
Yeah.
answer.
Yeah.
That if
Can
hydrogen
you
is
answer?
flammable, hydrogen is flammable and explosive. What are the protection of? Okay, no, flammability of hydrogen is not very high. It is a bit more flammable than gasoline, but gasoline is also flammable. If you create a spark and the gas station in Indonesia, it's very wet. You never see an explosion on the gas station, on the pompa bensin. In the US, you see many explosion on the pompa bensin because of that, because of spark. So in our hydrogen vehicles, because we build it in China is still the same like in the US. Sorry, in Indonesia, it's very wet, very humid. So we don't see that problem. We don't see spark problem. But to be able to, we also put a precaution on how to eliminate spark first. Second, we put this is an hydrogen car. There is always what is called hydrogen detector. Hydrogen detector will detect fire or leaks, and it creates a buzzing sound on that. So in the hydrogen, there is what it's called an invisible fire. Invisible fire, if you know you're in the oil industry, you should know this. Invisible fire is actually fire that is very hot. You don't see it, but suddenly it will create a burn effect. So we put a precaution on that as well. If you see a spiritus, and the flame of a spiritus in Indonesia is spiritus, what is it? Spiritus in the US is methanol. So spiritus create a blue flame. It's gasoline or normal flame, it create red or orange flame. Spiritus is blue. Hydrogen is no color. So how do we? So we put the precaution to remove or to identify if there is a flame like that as well.
Okay. So yeah, anyone want to raise hand and ask directly to Chadanet?
Well, there are many of them.
Yeah,
Okay,
this
okay, here, I'll just
in the chat box. Yeah, in the chat
let
box.
me let me answer quickly one by one. It's easier to maintain if it is compared to the battery EV. Yes, it is the same way to maintain it. It just have to have more cleaner to have it. So another one is this hydrogen fuel cell will be able to in plug-in form or use in light vehicle that are already ready? Yes, it is. But we can do it, but I don't know if it's gonna show out in Indonesia. We are trying to do it in Europe or the US first. So that's it's. So from the YouTube, I don't know if somebody can relay the message to me, then I'll just answer it quickly before we close.
Do you want to share from YouTube?
Oh, there is from the YouTube. There is it says over here. There are some questions. Oh, there is a question from YouTube.
The question, question from YouTube. Yeah, is fuel cell EV system is easier to maintain?
Pretty much the same when you maintain like the EV. It's just fuel cell EV has to be a bit more cleaner. That's it. That's about it.
Yeah, actually for the battery, maybe we have to change the battery after 5 or 10 years because as the current condition also that all the car manufacturing that for the warranty like a 5 or 8 years or 10 years because need change to the battery. So how about the fuel cell?
Don't need to worry about that.
We don't need to change the component or
no. Fuel cell is much easier to maintain, and you don't have to change your fuel cell. If your fuel cell is broken, you just go remove one of the stack and put it back. That's it. It's easy to fix it.
So like in US, yeah. Go ahead, Chandanet. Go ahead.
Now, before I close, I like to. I don't know how the ITS. There are two teams working on the fuel cell, and I really appreciate the student who work on that. One is the material engineering. The other one is the chemical engineering. Just keep working on what you do. Ask your your docent help. If you need my help, I could help you. If you could contact me anytime. So, and one of the things is that you have a challenge to build a fuel cell. My suggestion for you, not just only to go for a challenge to build fuel cell vehicles and go contests and here and there. No. Just create fuel cell module itself. Not just the way you create a fuel cell module is just go to the fuel cell store. There are several kind of website that has a fuel cell stores, and then create a stack on the fuel cell. So it's very simple. You can stack it up, create a stack, and then create your fuel cells and make it as a project for the student project. And then you start showcasing it. Now, the idea is this. It's not about that. You go to the contest and doing it. No. When you graduate, you build a company, a startup that is based on the fuel cell. There are so many uh, uh, investor company called venture capitals or angel investor that will put money on it. So that is your aim. That's put it in your mind. Just build a company as soon as possible. Maybe you work for other people for maybe 2 or 3 years or 5 year max before you get married or uh, build a company. And your work will go longer, will go farther away, and you will help many people that you might not even think before. So that might be my last message. And then don't put your dream only in Indonesia. Put your dream all the way to the farthest end of our solar system. Go there. I would like to see some people from ITS someday who will go there in Mars. Mars is a CO2. Mars atmosphere is CO2. CO2 with the methane, the CH4 will create hydrogen, will create fuel. CO2 itself is fuel. So think about that. Think about what you do and what the Mars is doing. Mars is going to be our second home. We're not going to stay in Earth any line. In 100 years, 200 years, human already will have some kind of a what do you call it? Settlement in Mars. If you have you been to Singapore to see the dome of the Singapore has a several touristic dome. That's actually originally where people are going to live in Mars in a dome like that. But it's very comfortable. I was there, and the dome is nice. The tourists are walking around. You see the different kind of a climate, but that's how you live in Mars. But that's how it is. You're not gonna. Your grandchildren might already go to think about it, but just don't put your dream only in Indonesia. Spread your wing, go somewhere. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Cak Janet, sorry, maybe is it possible, because you are talking regarding for the research, so is it possible that maybe we'll be join for the research in like ITS in the chemical engineering? So how about the research for the fuel cell? Is it possible? How do you do for this? And then is it okay? Yeah, for the material.
Yeah. They're already doing it right now. I know that there are two teams I mentioned to you, right? There are two teams.
Yeah.
Okay. So yeah, it's possible. It's already done right now. There are material engineering doing the research, and the chemical engineering should also doing the project as well. So let's just work together or compete with each other. That's how you do it. If you compete with each other, it's much better because people will, have better energy when it's got to see like somebody next door doing better than us. Let's do better here. So just compete with each other or work together.
Yeah, it's very nice. Okay, thank you very much for your insight and sharing for the today webinar. So yeah, this is I think already evening, yeah, almost night in your time. I don't know, it's by 10 o'clock or 9 p.m. 10 p.m.
My time is almost 12 right now.
Almost 12, yeah. Okay. Yeah. So it's just thank you very much, Jazakallah khairan Hatsiro. So hopefully that your sharing your knowledge will be fruitful and useful for our team in ITS and then and all the students in Indonesia. Sorry, there is the last question. Is it possible?
Sure.
If I get to you,
sure.
Yeah, in the chat box. This is from
Yeah,
Ranga. So if there's any voltage drop on fuel cell, we just can remove the cell and replace it in the new one. And there are treatment for the cell. My lab actually got a fuel cell and the output voltage is dropping. So if there's a treatment that we can try, we really like to try it.
Okay, so there are a couple of things. The reason why it's fuel drop. Maybe your electronics. Just check all of these electronics coming out of the fuel cell. Something wrong with it. If it is coming from the fuel cell or the dropping, that means something wrong with the stack. If something wrong with the stack, you just remove it and fix it. Most likely, it's a leak. There is a leak in it. So my suggestion is remove all of the stack and put a nice, better glue. The lem lagi, there's maybe the what do you call it, the packingnya, about the sealnya. The seal is not tight enough. Just retie it and then screw it up. That's it. So just play around with that. Electric, check on the electric connections, and secondly, if there is a leak, the gas leak, most likely is gas leak because it's dropping.
Okay, thank you very much, Chadanet. So, yeah, before we wrap up our session, maybe I can share. Yeah, this I can share slide. Yeah, anyone can you confirm that? Can you see it, my slide?
Yes.
Hello. Okay. So yeah, actually, yeah, before we wrap up this webinar, so this is our BP based on the BP outlook energy by last year 2020, that all the oil and gas company now, we are on the transition, energy transition, and we didn't call again for the international oil and gas company, but we call with the integrated energy company. Why? Because we are not only because we know that for the oil and gas producing will be reduced, and that our future, that we will go for the net zero carbon as sooner before 2050. So as what is our conclusion, that there are green hydrogen, blue hydrogen, and green hydrogen. So now, maybe for the current situation, that a lot of the gray hydrogen, but all our planning in the future for the blue hydrogen and green hydrogen. So actually, for the green hydrogen is we can produce with the electrolysis, and then for the blue hydrogen, then we need the natural gas. Maybe not we maybe you are listen regarding for the gasification from the coal. So this is maybe for the blue hydrogen. As you know, in UK, in Europe, that by 2030, that BP maybe will they need the hydrogen like a 20%, and BP also already to preparing regarding this, that we create the we join operation with the Daimler, BMW, and Volkswagen, that we create charging station, digital charging station, maybe for the EV, but I don't know, for the next year we are still preparing for the hydrogen. So how it can be used for the hydrogen, that as Cak Danet mentioned, that for the hydrogen is for the heavy transport, for like trucks, and then for the bus, even this is possible also for the car, and also that the delivering heat to building also. So you can see it in here, that our future energy, that hydrogen is one of the our future energy, because as the Paris Agreement, that we want to get the net zero carbon 2050 or sooner. So what is a hydrogen that will spend for the maybe 20 or 30 years more, that 25% in transport, and then 40% in industry, and then 80% in power, and then 17% for the building. So we need the green and blue hydrogen. So that's why you are the future generation that, as Janet mentioned, you know that you have to courage and develop and dig all the opportunity regarding for the future energy. Then the second thing that this is that I mentioned to you. So you know, BP now is they have 70,000 for the current situation for the EV charging station, but our target like 70,000 charging station for the EV by 2030. So that's why we are collaborate with the BMW, Daimler, and then also for Volkswagen also. And then next, I would like to share this one from Toyota. So maybe this is you can see what is the new product from Toyota Mirai.
Once again, give your virtual applause to our speaker and moderator for such an insightful discussion. Thank you, Mr. Danet and Mr. Lebda, for giving us more information about hydrogen fuel as eco-friendly resources.
Now, we are going to award the Fendel to our speaker and moderator, which will be given by the Committee of Chernival 2021. To the Committee of Chernival 2021, may direct the virtual Fendel to Mr. Danet and Mr. Lebda.
All right. Can you hear my voice? Okay. Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself first. My name is Arik Andika Farsha. I'm the representative of the Committee of Chernival 2021. In here, I would like to give a virtual Fendel to our beloved moderator and also our beloved speaker today. And for the first is for our moderator, Mr. Lebda Prakoso STCCME, or maybe in Indonesia and Surabaya we call this Cak Lebda. Yeah. Thank you very much, Mr. for attending and for willing to be our moderator and lead the discussion session on the previous webinar. And maybe we can take some picture as documentation for our session today. So is it okay for you?
Yeah, thank you very much.
Maybe for the committee can help us to take the screenshot or picture. Okay. We will count down it in 3, 2, 1. Okay, thank you very much, Cak Lebda.
Okay, you are welcome.
Okay, and also for our great speaker, Mr. Danet Surya Tama. Yeah, Surya Tama PhD. Thank you very much, sir, for willing to be our speakers and share your knowledge about hydrogen fuel resources. And as a younger generation, I really hope one day we can make our own company in hydrogen fuel in Indonesia. And maybe like Calebda before, I want to take some picture with you as documentation for this session. Is it okay? Yeah, okay. Maybe for the committee, you can help us to take some picture or screenshot the screen. We will count down it in 3, 2, 1. Okay. Thank you very much, Cak Danet, for being speaker today. And I hope everyone in this room and all the participants can get all the insight from the Mr. Danet and Mr. Lebda. And I really hope we can get better into the future. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
After taking attention for webinar, we will refresh you with our entertainment, a traditional dance performance named Sparkling Surabaya Dance.
For your information about this dance, Sparkling Surabaya is a dance that describes the identity of the people and city of Surabaya. It was created by Dias Tiarni on 207. The aim of this dance is to welcome the 714th anniversary of the city of Surabaya with the name Surabaya Sparkling. This dance is then called the Sparkling Surabaya Dance, which is packed with equality and beauty in every moment, depicting the identity and spirit of the people of Surabaya that always shines.
Traditional elements such as clothing, dance movements, and traditional East Java music are packaged in a modern style so that they present something different and rich in artistic and cultural values. This movement illustrates the egalitarian and not slow nature of Surabaya's modern society. Sparkling Surabaya dance was introduced to the wider community, is often displayed in various celebrations or cultural events, both domestically and internationally. In addition, this dance is also appointed as one of the icons of the city Surabaya because of the values in it that describe the city of Surabaya. Without further ado, please enjoy the Sparkling Surabaya dance.
Surabaya kota metropolitan kelap-kelip, lampu nang dalanan. Ayo konco ngundang wisatawan mlaku-mlaku nang tunjungan. Rame-rame bebarengan.
Wow, such a wonderful performance, right?
That's right.
There, we can know more about how Surabaya is, especially for those of you who haven't came to Surabaya, Indonesia.
After this, we will take a look together about the after movie of ICECC 2021. Please.
through the night, in our bones we can feel it. Aiming for the stars against the sky. When we are together, we are bright. We'll light up. We've been waiting for this moment to come. We were made for this adventure. We feel it in our blood. We'll light up. Eyes open wide and the world is before us. We are the sound of a beautiful chorus, holding to the feeling, you and I. When we are together, we are bright. We'll light up. We've been waiting for this moment to come. We were made for this adventure. We feel it in our blood. We'll light up. We have everything we need and we know we were made for this adventure and we were made to go. We'll light up. We'll light up. Aiming for the stars against the sky. When we are together, we are bright. We'll light up. We've been waiting for this moment to come. We were made for this adventure. We feel it in our blood. We'll light up. We have everything we need and we know we were made for this adventure and we were made to go. We'll light up. We'll light up. We'll light up.
Now, we are going to the agenda that everyone, especially to finalists of ICECC 2021, waits for. It's the announcement of the winner of ICECC 2021.
Then, we are going to hear some words from the first winner Indonesia Chem-E-Car Competition 2021, Team Spectronics XX from Institute Teknologi 10 November. For Team Spectronics XX, the time is yours.
Okay, hello everyone, good afternoon. Okay, thank you. We are from Spectronics Double X is very excited to participate in this competition and very grateful to the entire of Chernival and especially for the ICECC 2021 committee for successfully initiating the first ever online race chemical engineering Chem-E-Car competition. Even though this year ICECC is held during the COVID-19 pandemic online situation, but we are very enjoyed every moment of the event. And lastly, we are hoping that in the next year we can meet each other and help the offline of ICECC competition. Thank you.
Congratulations to all the winner of ICECC 2021. Thank you to the all participant, committee, and others supporting to make our event success.
Well, thank you very much for the insightful and very informative information given by our speaker, Mr. Danet Suryatama, PhD, as the CEO founder Electric Car LLC from Michigan, USA. And also, thank you very much to our amazing moderator, Mr. Lebda Prakoswo, STCCME.
Ladies and gentlemen, those are all the agenda we have presented to you today. But before that, we are going to take a photo together by screenshot on Zoom screen. So for all of the participants, please turn on your camera and use the virtual background that is provided by committee.
To the operator, how many slides that will be screenshotted? Okay, I see. Okay, we will wait to all the participants to turn on their camera. Tunggu kode dulu. We will wait to all the participants to turn on their camera. Are you ready? Okay, let me start. Okay, let me count in the count of 3. In 3, 2, 1, action. Okay, go to the next slide. 3, 2, 1, say cheese. Okay, go to the next slide. 3, 2, 1, cheese. Okay. Okay, go to the next slide again. I will count in the 3. 3, 2, 1. Okay. How many more? Okay, go to the next slide again. In the 3, 2, 1. Okay, don't forget to cheese. Okay, last slide. Okay, I will count in 3, 2, 1. Okay.
Okay, thank you for all the participants who participating us on our webinar. Now it's time for us to say goodbye. Thank you to all participants for actively participating in this awarding day of Indonesia Chem-E-Car Competition 2021.
I'm Jana.
I'm Diana.
And I'm Yagi.
We hope to see you again. We apologize for our mistakes while we are being the master of ceremony. Well, that's all for today.
See you in ICECC 2022.
The world keeps evolving. The times keep changing. The new generation of technology. The new generation of information. They bring the future before us. Institut Teknologi 10 November, a place where the spirit of heroism underlies the new generation to research and innovate in technology. The University of Heroes, ITS. ITS is one of the best science and technology universities in Indonesia, which was founded by Dr. Angga in 1957. In every step, ITS focuses in advancing education, research, management, and community service. As an incorporated public university, ITS has been able to manage autonomously the policy of academics, organizations, finance, students' affairs, human resources, facilities, operational, and infrastructure.
In the spirit of Indonesian heroes, during the battle in the 10th of November 1945, ITS always makes efforts to be the best in education, research, and community services, especially in the fields of industry and maritime. ITS also actively contributes to the nation development, and in the future, ITS will become an entrepreneurial university with world-class reputation.
ITS has many achievements. Both national and international achievements prove that ITS keeps growing and gives the best contribution to the nation of Indonesia.